Ever wondered how the intricate device you're using to watch this video came into existence? Let's journey back to the 17th century. Our voyage begins in the year 1642 with a brilliant French mathematician named Blaise Pascal. This young prodigy, at just 19 years of age, gave the world one of its first mechanical calculators, the Pascaline. Considered a marvel of its time, the Pascaline could perform basic arithmetic operations, such as addition and subtraction. It was a sturdy, rectangular box with dials representing numbers. Turning these dials would allow users to carry out their desired calculations. But hold on, Pascal's invention wasn't the only early computing device worth mentioning. A few decades later, another mathematician, Gottfried Wilhelm Leibniz, improved upon Pascal's design. He invented a calculator, aptly named the Leibniz calculator, that could not only add and subtract, but also multiply and divide. This was a significant leap forward, demonstrating that these mechanical devices could perform complex calculations. And then there was Charles Babbage, an English mathematician and inventor, often hailed as the father of the computer. Babbage proposed the concept of a difference engine in the 19th century. This machine was designed to compute mathematical tables, a task that was time-consuming and prone to human error. Although Babbage's difference engine was never fully built during his lifetime, it was a visionary concept that further pushed the boundaries of what these early calculating machines could do. These early devices, the Pascaline, the Leibniz calculator, and Babbage's difference engine, were the precursors to the computers we know today. They were the first steps in a long journey of technological evolution. In their time, they were revolutionary, bringing a new level of efficiency and accuracy to mathematical computations. These early devices laid the groundwork for the technological revolution that was yet to come. From mechanical gears to the humming of electricity, the 20th century took a major leap in computer technology. As we bid adieu to the 1800s, the world of computers was about to take a radical turn. And it all started with the Eniac. The Eniac, or the Electronic Numerical Integrator and Computer, was a marvel of its time. Developed during the 1940s, it was a far cry from the mechanical calculators of Blaise Pascal and Gottfried Leibniz. Eniac was one of the first fully electronic computers, a dazzling behemoth that consumed a staggering 150 kilowatts of electricity. It was a machine that transformed computing, laying the groundwork for the computer revolution that was to follow. But the Eniac was not without its challenges. Its complex system of vacuum tubes, switches, and cables made it a difficult beast to maintain. Breakdowns were common and troubleshooting was a nightmare. But as the saying goes, necessity is the mother of invention. And in this case, the necessity to make computers more reliable and less cumbersome led to a groundbreaking innovation: the transistor. The 1950s heralded the era of the transistor, a tiny device that would forever change the face of computers. Transistors replaced vacuum tubes, offering a more reliable, smaller, and energy-efficient solution. They were the building blocks that allowed computers to shrink from room-sized giants to desktop-friendly devices. The transistor was a game-changer. It was the key that unlocked the door to a new age of computing. With transistors, computers became more reliable, more efficient, and most importantly, accessible to a wider audience. The era of room-sized, power-hungry behemoths was coming to an end. The stage was now set for a new player to enter: the personal computer. The 1970s heralded an era where computers began to find a place not just in research labs, but also in homes and offices. It was a time when technology took a quantum leap, courtesy of the introduction of microprocessors. Microprocessors, or chips as they are often called, are essentially miniaturized versions of entire computers. Imagine having the power of a room-sized computer of the 1960s in the palm of your hand. That's what a microprocessor offered. This development was a game changer. It meant that computers could be made smaller, cheaper, and more accessible to the average person. It was the dawn of the age of personal computers. The first microprocessor was developed by Intel, a company that would go on to become a giant in the semiconductor industry. The Intel 4004, as it was called, had the processing power of the early room-sized computers. But it was just the size of a fingernail and consumed significantly less power. This tiny chip opened up a world of possibilities. Among the first to capitalize on this technology were two iconic companies of the computer era: Apple and IBM. Apple introduced the Apple II in 1977, a machine that was user-friendly, had color graphics, and was affordable. It was a hit among consumers and set the standard for personal computers. Not to be left behind, IBM introduced the IBM PC in 1981. IBM's reputation in the business world gave the PC credibility, and businesses across the globe started integrating computers into their daily operations. The IBM PC also had an open architecture which allowed other companies to produce and sell compatibles. This led to an explosion in software development. With the advent of these machines, computers transitioned from being a tool for scientists and researchers to an everyday device for individuals and businesses. It was the democratization of computing power, as computers were now in the hands of the people. With computers now a household item, the next step was to connect them all. As we stepped into the 90s, the internet revolutionized what computers could do. No longer were these machines isolated entities, crunching numbers and processing data in solitude. With the spread of the internet, computers became interconnected, opening up a world of possibilities. This era can be best described as the birth of connectivity. The World Wide Web, a system of interlinked hypertext documents accessed via the internet, came into existence. It was like a massive digital library, a decentralized network where every computer could access and add to the collective knowledge of humanity. But what made this possible? The answer lies in the Transmission Control Protocol and Internet Protocol, or TCP/IP. This set of communication protocols allowed computers to send and receive data across shared or public networks. It was the language of the internet, and once computers learned to speak it, the world was never the same. The 90s also saw the rise of tech giants like Microsoft and Google. Microsoft, already a key player in the personal computer market, seized the opportunity and made the internet more accessible for everyone with their Internet Explorer browser. This browser came bundled with their Windows operating system, thus reaching millions of users around the world. Meanwhile, Google started as a simple search engine, but rapidly evolved into an internet behemoth. They revolutionized how we find and access information online, turning the vast and chaotic World Wide Web into a searchable, organized entity. The contributions of these companies, along with many others, transformed our relationship with computers. They were no longer just tools for work or play. They became portals to a global network, a unified digital landscape where information, entertainment, and communication converged. This internet era didn't just change what computers could do, it changed how we used them, how we thought about them, and how they influenced our daily lives. It was a shift from using computers to do tasks to using them to connect with the world. The internet era paved the way for an even more personalized computing experience. Today, computers are not just desktop devices, but are in our pockets and on our wrists. The advent of smartphones and tablets has revolutionized the way we integrate technology into our daily lives. These devices, small enough to fit into our pockets, now possess computing power that would have been unimaginable just a few decades ago. It's not just the hardware that has evolved, software developments have kept pace, making these devices incredibly versatile. From sending emails and browsing the internet to editing photos and producing music, there's virtually nothing these pocket-sized computers can't do. But the story doesn't end here. The rise of cloud computing has further changed the game. Instead of being restricted by the physical limitations of our devices, we can now tap into vast networks of computers located elsewhere. This has allowed us to store more data than ever before and access it from virtually anywhere in the world. It has also made it possible to run complex programs and algorithms without needing a supercomputer at our disposal. And then, of course, there's artificial intelligence, or AI. AI is reshaping the landscape of computing as we know it. It's not just about creating machines that can think. It's about creating systems that can learn and adapt, that can understand and interact with the world in ways that were once the exclusive domain of human beings. AI is now at the forefront of everything from predictive text and voice recognition to self-driving cars and personalized recommendations. From the Pascaline to AI, the journey of computers is a testament to human ingenuity. In a relatively short span of time, we've gone from simple mechanical calculators to devices that can fit in our pockets and perform tasks that would have been considered magic not too long ago. As we continue to push the boundaries of what's possible, who knows what the future holds?